Quantum computing allows us to do new calculations that just wouldn't be possible otherwise.
So quantum is really the future of computing. Instead of using a digital bit, we use what's called a qubit as our foundational building block. And what that enables is it enables an exponential increase in compute power. And the promise and the excitement of what that will deliver is it will enable us to do things that we simply can't do today with the available compute power. So if you take things like discovering new drugs, optimization of battery materials, simulation of things like the climate, the opportunities for quantum with this exponential compute available are really going to change our world.
We feel that we're ahead of everyone else in the integration of the QSOC and bringing the qubits and electronics together into one die. And we think this is the beginning of being able to scale into large-scale quantum computing to really bring it to the masses. Temperature is a key element. 0 Kelvin is absolute zero, as the coldest could ever possibly be. We operate at a relatively hot temperature of 1 Kelvin to 2 Kelvin. Imagine 1 or 2 degrees Celsius above the coldest it could possibly ever be. And just to put it in context, space is at 2 Kelvin approximately, so it's actually colder than space. It's significantly smaller than a big system. It means you can use far less wires going in and out of the system. That means you make it much, much smaller and make the power that the system uses is much more comparable to a regular server and doesn't need a big data center. And we're talking several orders of magnitude. So we're talking about going from 100 megawatts down to 2 kilowatts. So 5-6 orders of magnitude.
So for the analog design, we use the Virtuoso Studio. So we use that extensively to develop the fine precision and fine control of the qubits from a voltage point of view and also from a measurement point of view. In terms of the layout, it's the full Innovus flow for the back-end layout where we're integrating several million gates into the chip. For the verification, the physical verification flow, we use the Pegasus tools. For digital simulation is Exilium and that set of tools. Also then for the RF, we've used Clarity, that allows us to seamlessly integrate RF analysis and RF simulations within the design itself.
The coolest thing is nobody else is doing it this way. We're putting the electronics and the qubits together in one die inside a cryostat, and nobody else is doing this. Cadence tools, we know they're capable of scaling up to full reticle size, and that's a key element that we want to be able to do in the future.